Hi and welcome to Chemipedia chemistry classes for 11th and 12th standard. In this video, I'm going to discuss about previous year NEET questions from metallurgy lesson. Okay, right. Now let us straight away go to the questions. Question number 1. Which one of the following is malachite? Which one of the following can be called as malachite? Look at the options. Option A, CuCO3 dot CuOH twice. Option B, CuFeS2. C is CuOH twice. Option D is Fe3O4. Now from this 4, which one is called as malachite green? So that you have to find out. Okay. Now the answer is option A, copper carbonate copper hydroxide, CuCO3 dot CuOH twice is generally called as malachite. So option A is the right answer. Okay, right. Because the other compounds, that is CuFeS2, it is called as copper pyrite. It's nothing but the chief ore of copper. The third option, CuOH twice, which is called as petinite. The last one, Fe3O4, which is nothing but an ore of iron, which is called as magnetite. So that the correct answer is malachite, option A. Okay, now we go for question number 2. Identify the incorrect statement among the following. So you are given 4 options. Among that, one is incorrect. That you have to find it out. Right. So the scientific and technological process used for isolation of metal from its ore is known as metallurgy. So it's a correct statement because the various process which are involved in extraction of a metal from its ore is what we call it as metallurgical process, isn't it? Right. And second one, minerals are naturally occurring chemical substances in the earth crust. Yeah, that is nothing. Minerals are nothing but metal compounds which are formed by nature in the earth crust. So option B also right one. Look at option C. Ore are minerals that may contain metal. So you know what is the differences between mineral and ore? Ore also nothing but a mineral, isn't it? Which we use for extracting a particular metal, isn't it? Because ore contains more amount of metal compared with mineral, isn't it? So option C also right one. Ore are minerals which may contain metal and they are used for extraction of metal, isn't it? Right. So look at option D. Gangue is an ore which is contaminated with undesired materials. So here you are given that gangue is an ore. Okay, so actually gangue is not an ore at all. Gangue is not an ore at all. Actually gangue is a earthy impurity which is present along with the ore, isn't it? So that here the last one is the incorrect statement. Okay, so the incorrect statement is option D. Gangue is an ore which is contaminated with undesired material. But actually ore is contaminated with the undesired material, what you call it as gangue. Okay, so that the option D is the incorrect statement among the given 4. Okay, right. So now let us go for question number 3. Okay, right. Cassiterite is an ore of which of the following metal? So cassiterite is an ore of which of the following given metal? So stibbium, antimony, nickel, tin or manganese. Okay, so actually cassiterite is an ore of tin. So because cassiterite is nothing but tin oxide actually. What is cassiterite? It's nothing but tin oxide, SnO2. Okay, or which is also called as tin stone. The other name of cassiterite is nothing but tin stone. Okay, right. So that question number 3, correct option is option C, tin. Right. Question number 4. Which among the following is called as fool's gold? So among the given 4, one compound is called as fool's gold. Okay, so which one among them is the fool's gold? Okay, the answer is option D. Actually you are given iron oxide, FeO, ferrous oxide. Option B, ferroso-ferric oxide, Fe3O4, which is also called as magnetite. Then option C, CuFeS2, which is nothing but copper pyrite. The last one, option D. Option D is given as FeS2, isn't it? So FeS2 is the right answer. Okay. This iron sulphide is actually called as fool's gold. Fool's gold. So which is also called as iron pyrite. The mineral name of FeS2 is nothing but iron pyrite. It is actually called as fool's gold because it has a fine metallic luster. It has fine metallic luster and it has a brass yellow color. So it has yellow color, almost looks like a gold. So iron sulfide looks like gold with yellow color and fine metallic luster. That's why iron sulfide is called as full gold. It's not a real gold, which means not a real gold. Okay, right. So now let us go for question number 5. The formula of azurite. Formula of azurite is, okay, right. You are given different copper carbonate and copper hydroxide composition, isn't it? Right. Here the answer is option C. Answer is option B, which is nothing but Cu twice CuCO3 dot CuOH twice. So already we have discussed a similar question. First question, which of the following is malachite, isn't it? Which is nothing but CuCO3 dot CuOH twice. That is a formula of chemical formula of malachite. Whereas here what you are asked is, you are asked to find out the azurite compound, isn't it? Actually option B is the right answer. Option B is the right answer, because azurite is nothing but twice CuCO3 dot CuOH twice. This is the correct answer. Okay, so the difference between malachite and this one, in malachite you have one CuCO3 dot CuOH twice. Here you have twice the time of CuCO3 and once the time of CuOH twice. There is a difference between malachite and azurite. Okay, right. Now let us go for question number 6. Yeah, so the question is, which one of the following ore is best concentrated by froth flotation process? Okay, so for which of the following ore we are using froth flotation process? Okay, you know very well that we have different concentration process, which is nothing but the process by which the earthy impurities are removed. So different ores are subjected to different concentration processes, isn't it? For example, heavy metal oxides are concentrated by gravity separation or hydraulic washing method. Sulfide ores are concentrated by froth flotation method. So likewise, magnetic substances by electromagnetic separation and so on, isn't it? Right. Now here the question is, which of the following ore is concentrated by froth flotation process? As I said already, froth flotation process is used for concentration of which kind of ore? We use for sulfide ore, isn't it? So now from the given 4 options, we have to find out which one is sulfide. Okay, actually you are given magnetite, siderite, galena and malachite, isn't it? Magnetite is nothing but iron oxide, Fe3O4. Siderite is also an iron compound, iron carbonate, FeCO3. Galena is lead sulfide, PbS. Malachite already we have discussed is nothing but a mixture of copper carbonate and copper hydroxide. Okay, so among this, which one is the sulfide ore? Galena. So galena only concentrated by froth flotation process. Okay, right. So now the answer is 6th question. The answer is galena. Okay, because it is a sulfide ore, so that it is concentrated by froth flotation process. Okay, right. Now we go for question number 7. Question number 7 is a match type of question. Okay, you are given some ores as well as the metals which are extracted from that ores, isn't it? Right. The first one siderite. The second one kaolinite. Third one malachite. The last one calamine, isn't it? So actually calamine is a ore of zinc. It's nothing but zinc carbonate. Okay. Then malachite is nothing but copper carbonate, copper hydroxide, isn't it? Right. Then siderite is nothing but, just now we saw, isn't it? Siderite is nothing but iron carbonate, FeCO thrice, isn't it? Iron carbonate. Then kaolite is nothing but a compound of aluminium. So I have given the formula: siderite with FeCO3, kaolinite with formula Al2O3 dot twice SiO2 dot twice H2O. Is nothing but hydrated aluminium silicon oxide. Okay, malachite already we discussed, copper carbonate and copper hydroxide. Calamine is zinc carbonate. Okay, so now the answer is siderite iron compound. First one C, second one D. First one C, second one D, third one B, fourth one A. So option C is the right one. Okay, so look at the option C. Option C is the right answer. First one C, second one D, third one B, fourth one A. Okay, right. So now we go for question number 8. So what is question number 8? The oil which is used as a frothing agent in froth flotation process. So froth flotation process for formation of froth, we use an oil. So the question is which can be used as a frothing agent. Okay, right. So you are given 4 options. One is pine oil, another one mustard oil, third one coconut oil, fourth one is nothing but olive oil. Okay, the answer is pine oil. So actually pine oil is used as a frothing agent. Pine oil is used as frothing agent. So option A is correct. Either pine oil or eucalyptus oil. Either pine oil or eucalyptus oil is generally used as a frothing agent. Okay, right. Now question number 9. In froth flotation process, which of the following can be used as a depressing agent? Which of the following is used as a depressing agent in froth flotation process? Okay, right. So froth flotation process, we are able to concentrate 2 types of sulfide ores. The one is a sulfide ore which is containing non-sulfide impurity. The other one, a sulfide ore which is containing sulfide impurity, isn't it? A mixed sulfide. Among that, one is the ore, another one is the impurity. For such a case, the impure sulfide should not come along with the froth, isn't it? For that, we are supposed to reduce the frothing ability of that impurity sulfide, isn't it? For that, we add a substance, what you call it as depressing agent. Depressing agent is the one which reduces the frothing ability of the impure sulfide. Okay, so for that, we use chemical substances such as sodium cyanide or sodium carbonate. Generally, sodium cyanide or sodium carbonate are used as depressing agent in froth flotation process. So look at the options. The options are sodium xanthate, sodium sulfide, then sodium cyanide, on all the above. Okay, so as I said already, sodium cyanide can be used as a depressing agent in froth flotation process. Sodium cyanide, or you can use even sodium carbonate also. Okay, right. So now question number 10. What is the role of aniline or Cressol in froth flotation process? In froth flotation process, either aniline or Cressol can be used. So what is the role? What is the purpose of adding aniline or Cressol in froth flotation process? Okay, right. Here the answer is stabilizer. Actually, the answer is stabilizer because so in froth flotation process we add aniline or Cressol, isn't it? The role of that compound is aniline or Cressol enhances the non-wetting ability of mineral and stabilize the froth. Okay, so actually the purpose of adding aniline or Cressol in froth flotation process is to make the mineral not to wet with water or to form a stable froth. Okay, so the role of aniline or Cressol in froth flotation process, it acts as a stabilizer. Okay, right. Now question number 11. The composition of copper matte is, so which of the following mixture is called as matte? Okay, right. So actually this is a mixture which is formed in the extraction of copper from copper pyrite. What are the various processes we have in the copper extraction, isn't it? We start with roasting. First we start with concentration. Copper pyrite being a sulfide ore can be concentrated by froth flotation process. The second stage is nothing but roasting. That concentrated ore is heated in presence of excess of air, isn't it? That copper pyrite CuFeS2 decomposes into copper sulfide and iron sulfide, isn't it? And iron sulfide is oxidized to iron oxide, etc., isn't it? Then the next step is nothing but smelting process, isn't it? In smelting process, the iron oxide reacts with silica and will be removed as iron silicate. So that end of the smelting process, almost all the iron sulfide are removed, so that we get a mixture which is a mixture of copper sulfide and a little of iron sulfide. We get a mixture of copper sulfide and a little of iron sulfide at the end of the smelting process. That mixture is what we call it as matte solder. Okay, right. So the answer for question number 11 is option A. So matte is nothing but a mixture of copper sulfide and iron sulfide. Here the copper sulfide is the major portion. Copper sulfide is the major portion, so which contains little of iron sulfide also. Okay. Yeah, this is what actually matte, copper sulfide plus little of iron sulfide mixture. Okay, right. So now let us go for question number 12. Question number 12 is based on roasting process. Okay. So roasting of a sulfide ore gives a gas X as a byproduct. So this is a colorless gas with choking smell of burnt sulfur, it causes damage to the respiratory organs, results in acid rain. Okay, so now the question is, so what is the gas which is released during roasting process? So generally, roasting process is used for converting a sulfide ore into oxide ore, isn't it? Okay, so now during roasting process, what will happen is the sulfide ore is getting converted into oxide. Along with that, a gas will be released. That gas released is nothing but sulfur dioxide actually. So there is a, that sulfur dioxide is a gas which is responsible for acid rain, isn't it? So the correct answer is option option D, last option. Okay, right. So just I give one example for that sulfur dioxide formation reaction. Okay, so look at the reaction. Is nothing but an example for roasting process. Okay, zinc sulfide, that is zinc blende, is roasted 3O2, not SO2. This is 3O2. When zinc sulfide is roasted, heated in excess of oxygen, so what you get is nothing but zinc oxide. That sulfide is converted into oxide. Along with that, look at the gas, what is coming out as a byproduct. You are getting sulfur dioxide, isn't it? So that the gas which is released during roasting process is nothing but sulfur dioxide gas. Okay, right. Now question number 13. Right, so in the extraction of which of the following metal involves besmerization? Okay, there you are given 4 metals: iron, silver, aluminium and copper. Among the extraction of one metal, there is a process called as besmerization. Okay, so besmerization is the process which is involved in the extraction of copper. Okay, because copper extraction, these are the various steps in the extraction of copper: concentration, froth flotation process, roasting, smelting, then besmerization. Okay, actually besmerization is almost the final step of copper extraction. Reduction of copper oxide into copper metal by its own sulfide. Okay, copper oxide into copper with the reducing agent copper sulfide. Okay, right. Now question number 14. Considering Ellingham diagram, which of the following metal can be used to reduce alumina? So alumina is nothing but aluminium oxide. The aluminium oxide can be reduced into aluminium using which of the following metal? Okay, for this you have to refer Ellingham diagram. Okay, this is nothing but the Ellingham diagram. So in which the temperature is plotted against delta G naught value. Okay, right. So according to Ellingham diagram, the metal which is lying below the diagram can act as a very good reducing agent for the metal oxide which is lying above. Okay, now the question is, which is used as a good reducing agent for reducing alumina, isn't it? Right. Now the answer is magnesium. Answer is magnesium actually, because look at, magnesium is lying below the series, isn't it? Whereas alumina is nothing but aluminium oxide, isn't it? This which is lying in the upper series, isn't it? So according to the Ellingham diagram, the metal which is lying below can act as a reducing agent for the metal oxide which is lying above, isn't it? So that magnesium can act as a good reducing agent for alumina, to reduce alumina into aluminium metal. Okay, the other options, iron, silver and copper. Iron, zinc and copper. Other 3 options are iron, zinc and copper. They are lying in the above series. They are lying above aluminium, so that they cannot be used as a reducing agent for alumina. Okay, so the answer is magnesium. Okay, so the concept is the metal which is lying below the Ellingham diagram can act as a reducing agent, better reducing agent for the metal oxide which is lying above. Okay, so the answer for question number 14 is magnesium. Okay, so magnesium can act as a very good reducing agent for reducing alumina. Okay, right. Question number 15. The first step of extraction of copper. So what is the first step which is involved in the extraction of copper? Okay, you are given 4 options. The first one, reduction of copper oxide with copper sulfide. So actually it's not a first step. Actually this is the last step. This is nothing but besmerization process. Reduction with iron. Actually we don't have reduction with iron. This is a step actually we don't have in that process. Okay. Option C, heating ore with coke. Heating ore with coke. In copper extraction we are not at all using coke. Then look at option D, roasting up copper to sulfide. Okay, so that is the correct answer. So that the first step involved in extraction of copper is nothing but roasting. After concentration step, what you have is nothing but roasting, isn't it? So that this is the right answer. Okay, right. Now question number 16. which process is used in smelting during metallurgy of copper? Okay, so which is the correct process which comes under smelting of metallurgy of copper? Okay, right. Self reduction of copper. So self reduction of copper comes under besmerization, last step. Option B, conversion of copper sulfide into copper oxide, which is nothing but the besmerization actually, isn't it, right? Then option C, iron sulfide is converted into iron oxide. Iron sulfide is converted into iron oxide. That is the right answer. Okay. Whereas in this process, this is the process which takes place during smelting of copper extraction process. Okay. So iron sulfide, which is a gangue material which is present in the copper pyrite ore, this can be converted into iron oxide in the smelting process. Once it becomes as iron oxide, then it combines with silica and will form iron silicate slag, which can be removed, isn't it? So that the right answer which occurs in smelting process during metallurgy of copper is nothing but conversion of iron sulfide into iron oxide. Okay. Question number 17. So it's a assertion reason type question. Okay. So assertion is hydrometallurgy process involves dissolving ore in a suitable region followed by precipitation by more electropositive metal. So hydrometallurgy is a type of metallurgical process in which a metal can be precipitated by addition of a more electropositive metal from its metal salt solution, isn't it? Okay, right. Then the reason is given, copper is extracted by hydrometallurgy process. Okay, so here the answer is option B is the answer. Both assertion, reason are true. Both assertion, reason are true, but reason is not a correct explanation of assertion actually. Hydrometallurgy, so first we add a suitable solvent with the ore, so that metal is getting dissolved in that solvent. Then from that the metal can be separated by addition of more electropositive metal. That's a correct statement. The reason copper extracted by hydrometallurgical process, that also correct one. Both are correct statements, but the reason what is given is not a correct explanation for assertion. Okay, so the answer is option B. Both assertion, reason are true, but reason is not correct explanation for assertion. Okay, right. Now question number 18. In the extraction of copper from its sulfide, actually copper is extracted from copper pyrite ore, isn't it? The metal finally obtained by reduction of cuprous oxide with what? Okay, so in extraction of metal, generally the metal oxide is finally reduced into metal using some reducing agents, isn't it? Whereas in the extraction of copper from copper pyrite, the cuprous oxide, so what do you get in the last step, is reduced by its own sulfide. Okay, so own metal sulfide here acts as a reducing agent. So the answer is Cu2S, that is copper 1 sulfide. Okay, I think you know what is that process. Actually, this is what the process what you have in this one, isn't it? Okay, so 18th one, look at that. Copper oxide form after a smelting process is getting reduced with its own metal sulfide. Here that cuprous sulfide or copper 1 sulfide on the acting as a reducing agent, so that you are getting blister copper, isn't it, with the release of sulfur dioxide gas. This copper what you get after reduction of copper 1 oxide with copper sulfide is what you called as blister copper, isn't it? Okay, right. Now let us go for question number 19. Question number 19. Right, what's question number 19? The slag formed in the blast furnace removes the impurities. So blast furnace actually we use for extraction of iron. So iron is extracted in blast furnace, isn't it? Right. So in the iron extraction process, we use calcium carbonate as a flux material. Okay, so that on thermal decomposition giving calcium oxide, that calcium oxide is used to remove silica impurity, isn't it? So here the answer is option A. Option A. The slag formed in blast furnace removes the impurity of silica. Okay, so slag is formed by the gangue material SiO2. Okay, so this was the actual reaction what we have in the slag formation. That flux material calcium carbonate dissociates to form calcium oxide and carbon dioxide. That calcium oxide form will combine with the silica gangue, which is present in the iron, that is hematite ore, and becomes as calcium silicate slag. Okay, right. So here the impurity gangue is nothing but SiO2. So that is the answer. So option A is the right answer. Okay, right. So now we go for question number 20. the metal oxide which cannot be reduced to metal by carbon. So you are given 4 metal oxides: aluminum oxide, lead oxide, zinc oxide, and iron oxide. Among these 4, one metal oxide cannot be reduced by carbon. For one metal oxide, carbon cannot act as a reducing agent, which is nothing but aluminum oxide. So aluminum oxide cannot be reduced into aluminum with the help of carbon as a reducing agent. The reason is aluminum is a strong reducing agent than carbon itself. Carbon is a strong reducing agent than carbon, so that the carbon cannot act as a reducing agent for alumina. Okay. So that aluminum is a strong reducing agent than carbon, so it cannot be reduced with the help of carbon. Okay. Right.